Hi everyone, in this video we are going to be talking about the proof of sine x squared plus cosine x squared equals 1. We are going to be proving this, of course, but I just wanted to note that this is the main Pythagorean identity. It's incredibly significant and very used, so it's great to know the proof of this, and I will help you with that. Okay, so let's get started. First, what I'm going to do is draw a right angle triangle, and suppose this is the angle x, okay? And normally the sides would be labeled A, B, and the hypotenuse C. We're being very general because we are proving a very general identity. Okay, so what I really need to do is figure out what sine of x is and cosine of x, then square them and add them to see if we can get 1. That's what our goal is. So let's figure out just sine of x and just cosine of x. We will later figure out sine x squared. So we're going to square that value we're going to find. And this squared is written here just to avoid confusion. That's how the notation works. But how do we find sine of x or cosine of x? Well, recall. So TOA. The S is the sine. The C is the cosine, and I'll explain what this is if you don't know. The T is the tan, but we are not working with tan. We just want to know sine and cosine. And by the way, I'm going to be working on this side, so I'm going to add these things after I square them and see if I get 1, like I said. Okay, what is sine? Sine of x of this angle is the opposite over the hypotenuse. The opposite is the B, and the hypotenuse is the C. So it's B over C. What is the cosine? The cosine of x is the adjacent over the hypotenuse. The adjacent of this angle is this, right here, this side. So it's A over hypotenuse, which is C. Great. So we know the basic sine of x and cosine of x. I just wanted to write down the, because we're going to need this, the normal Pythagorean theorem, because it's going to help us in the end. And we know this, right? It's simple. Okay, so what I'm going to do is take each piece and square it, right? Because we're going to add them, but we need them to be squared first. So if I square, so sine of x, if I square that, I get b squared over c squared. I just squared each piece right there. And cosine, actually it's going to be squared, right? Of x is going to be a squared over c squared, correct? Just squared each piece. And now we want to add it, right? We're going to do exactly what this shows. We want to add both of the pieces, this piece and this piece, and see if we can get 1. Let's do exactly that. Okay. So let's do b squared over c squared plus a squared over c squared, and see if we can get 1. Okay? So these two guys are under the same denominator, so let's put it under the same, just 1 over 1 denominator. This would be b squared plus, I'm going to write it the other way. Can I write this first and that? Just to avoid confusion. B squared equaling 1, hopefully. And let's look, now we need our Pythagorean theorem. Let's look at this. The Pythagorean theorem says a squared plus b squared is c squared. Okay, so c squared is the same thing as a squared plus b squared. And look, we got an a squared plus b squared. So we can substitute c squared for this. And we get c squared over c squared equaling 1. And does that equal 1? Well, yes indeed, because these two cancel. They're the same thing. And they divide each other and we get 1. Meaning this proof is absolutely correct and valid. Alright, thank you for watching and I'll see you in my next video.